I can give you Opera.
Opera is something that's required on the security table. What a way to start an episode. Welcome, folks, to the security table for our first episode of 2024. My name is Chris Romeo, joined as always by Izar Tarandosh and Matt Coles. I need to think up better nicknames for you guys, but it was the holiday season.
I have one.
You have one. Izar is that's not really a nickname, though. That's kind of an actual name. But I do have to think up some. I'll work on that with ChatGPT before the next episode. What we want to dive into is a LinkedIn post. So Bob Lord is a guy who works at CISA. His title is Senior Technical Advisor. And he wrote this interesting note about a week ago from when we were recording this. So right before the first of the year, right before New Year's. And here's what it says. I'll just read it to you verbatim to set you guys up here so you can then be prepared to react to it. And so here's what Bob writes, and I quote, "Just a quick thought on open source. If you are a software company and you use open source components, you own the QA, quality assurance, and security ramifications for using that component. You didn't write it, but you still own the customer security outcomes. If you find a vulnerability and create a fix, it is your civic responsibility to ensure all users of that open source library enjoy the added security." Civic responsibility. That sounds big. That sounds big. All right, Matt, I see you you're pondering. I can see some pondering in your eyes here. What's your first reaction to this statement?
So there's a bit to unpack here. Let's take each part. I mean, Bob is suggesting, I think, more than just that last line. The last line is the important part, but there's more to it, right? So if you use an open source component, you own the QA, the quality assurance, and security ramifications of using that component. That is true, right? If you build software and you use code, whether you're writing that code or you're inheriting that code, the collection of all that code and the thing that it creates is that company's responsibility. That makes sense, right? If you find a vulnerability, I guess, and create a fix for it. The question is here, there's a part of when you create a vulnerability, when you find a vulnerability, should you report it upstream? And we can talk about that, reporting upstream into open source projects. But should you report it or should you try to fix it? And I think the key part that Bob is calling out here is if you're using an open source component and you fix it for yourself, should you distribute it to the community? Should you push it back upstream so that all users of that component should be able to make use of the fix that you created that you're now going to be benefiting from as a software vendor? And this gets into civic responsibility. Yeah. So this becomes a question, I think, I think in corporate worlds, it becomes an IP creation / sharing question, right? So there's some legal implications potentially. There's certainly more things, whether it's a civic responsibility or not. I guess this goes down to, again, responsible disclosure practices and what the nature of open source components is, who's responsible for making fixes and distributing those fixes to users.
So, Izar, I want to get your take first, and then I want to back us up into that first. I want to dive deeper into the first section, the QA and security ramifications. But I want to get your initial take on this first.
I wish I had a Pope hat to wear here because it's so easy to pontificate. Right? But first of all, a shout out to CISA, you said he works at Bob Lord.
Yep. And
hey, love your guys' work. And we even wrote letters to you guys. But great job there.
No,
anyways.
Not hate mail.
No, definitely not. All constructive. But yeah, so I would say that there's no way not to agree with the first part that we're going to go back, which is the one where if you use it, then, hey, you own the QA and security. I don't think that's a given. But the second part, it goes away from the technical, it goes away from the, even from the what was it? The civic responsibility that just screams the ethics of it, right? And the IP generation, of course, brings, as the comments did, brings us straight back to, hey, what license are you operating under, right? But to me, the main point here is the moment you put civic responsibility in there, first question in this context that comes up to me is, you and what army? So
who's you
I
in
don't
this
fix
case?
it.
Who's you in
The
your case?
person who's telling me that I have a civic responsibility. So yeah, I fixed it. Why do you think that there's a civic contract here that means that I have to go and offer the fix to other people? Especially if you take into consideration the costs involved in terms of forward-looking, and as an open source maintainer, I think that Matt is also going to agree with me. Sometimes you get some really, really good patches. Sometimes you get some patches that are less good, right?
And, you just have to say thank you. Yeah, thank you for this input, and then you like delete.
Indeed, and I could go on for hours on that. Frankly, my experience has been mostly positive by a huge margin. I learned from every patch that PyTM gets. But my point is that, okay, so you fixed it. So now you exercise your civic responsibility and you push that up. What do you do tomorrow when another user comes and says that your patch borked his edge case? You stop what you're doing now and you fix your patch because now you also own that patch.
Yeah, it's like a commitment, right? It's a commitment forward. It's more than a patch.
There was a comment here by.
Well, so while you're looking up that comment,
by Michael Scovetta, Michael Scovetta, saying open source software provides tremendous value, but it's only free as in free puppies.
Yeah.
So we left free beer now.
Wait, I thought it was the other thing. I thought it's free as in puppies, not free as in beer.
Right.
No, free as in beer, not free as in speech.
Right. Free.
That's
free
the
from,
original, I think.
Free from cost versus free from responsibility.
Yeah, but the free puppies here.
There's hidden cost, which is like the free puppy, right?
And this thing got me viscerally because first, I love puppies. Who doesn't? And if you don't, I don't love you. But frankly, I mean, it's a puppy. You brought it in. You're taking care of it. And it's going to be with you, I hope, for a long, long, long time. It's going to give you joy. But you have to feed it and clean after it and take care of it, right?
Yeah.
So that, to me, in some cases, may easily trump the civic responsibility.
Yeah. I want to come back to that. Which is a
strong argument.
I want to come back to that. I want to unpack the first section of this because I know you guys are both like, yeah, this is good. This is fine. I don't know that this is as clean as we're making it sound like. And so if you're a software company, I love that. What are you guys, the puppy patrol here? You're like, I just made a noise, like I whistled. All right, so if you're a software company and use open source components, you own the QA and security ramifications for using that component. You own the QA, the quality assurance. So in reality, that statement sounds like something that should be easy to agree with. But when we think about the reality of how people use open source, you own the QA. So that means I got to write unit tests. I got to do regression testing.
No, I would be careful not reading too much into that.
Okay, so what's QA for using that component?
You own the usage, right? It is up to you as the software integrator. In this case, you're integrating code, right? Integrating somebody else's code.
Okay.
You are, I mean, you should have a development lifecycle that includes QA for the thing that you're building, and any components that you include should be covered, like code coverage, right? Should include the code paths that come in from that open source component. In that respect, there's no differentiation. I guess it's part of the whole system. You test the whole system, and if there are side effects that come out of that, you should hopefully be in a position of discovering that. You shouldn't, if you embed a web server, Tomcat or something like that, or Apache, and it has extra features that you keep enabled in your product, that's on you as the software vendor, right? You should close those off.
I own the vulnerabilities that exist in that software.
No, wait. We're talking QA now.
No. I'm trying to walk you into a path. I'm leading you down a path that I'm gonna
it's simpler
the table
than that.
at the end. But
It's simpler than that. Okay, when you're bringing in something that's open source, basically you are bringing in a promise. I promise you that this thing that somebody wrote, they promise you that thing that they wrote does A, B, C, D, and E.
okay,
It's your responsibility to make sure by using QA that it does what you need, no more, no less. And that includes the security clause. It's your responsibility to make sure that you're not bringing risk by incorporating that component.
You inherit what comes along with the component.
Exactly.
And by the way, the promise, this is where licensing, I think, actually is critically important. If you pull a component and it has the MIT license or the 2-clause or 3-clause BSD license, where it's basically use it as is, and you're free to use it as it comes, and there's no warranty implied. That promise is, as a component developer, we believe it works, but it's on you to figure it out. Does it work for you? As opposed to another license that may say we warranty its function or fit for purpose or whatever your language you want to use. That if it's a problem, come back to us and we'll fix it for you. That's a different promise.
Okay, so
Matt nails it when he says that when you inherit the thing, people forget that inheritances have taxes on them too. So you're not only bringing that thing and running around free and carefree saying, hey, I just found the component that does everything that I wanted. No, you have that tax. You have to pay care to what Matt is saying. You have to pay care to downstream. What does that do? You have to pay care to pay attention to how long is this thing going to be around, right? So there's a tax to be paid when you assume open source.
Let me ask another revealing question. So it'll be a leading question too, because watch the first one. This will be the lead, and then we'll come back around. So does either of you use open source components in anything that you do?
In the last 5 minutes?
No.
Yeah, I use open source applications or components, yes.
In things that you've built. In the last month, do you use open source components?
Constantly.
Yeah. Yes.
Okay, so have you created threat models for each of those components?
In my mind, yeah. My mind is a very threat model place.
But that would be the security. That would be security ramifications for using that component would technically be. So we should technically have a threat model for every third-party component that's being included inside of a.
No.
Time out.
Hold on. Well, that's ramifications. Security ramifications for using that component. I'm reading it off the page.
No.
That's not. Right. So as a person who uses a third-party component, an open source, let's open source, right? Or generically any third party, anything that comes from a third party, whether it's a desktop application or a software library or fragments of code, you certainly should be threat modeling it for your usage. That does not mean you're threat modeling its entirety, right? Okay. And it doesn't necessarily mean there's a formal threat model. So for instance, if I use, let's say I use an open source password manager. I know it has certain security properties, and I'm going to put that into my personal threat model. Now, I don't have that written down anywhere, but I have an understanding of how that impacts me, what its security posture is, and how it impacts me. Similar process may happen for a software application, but I'm not writing commercial software applications. If I was a commercial developer, or if I was doing this for PyTM, for instance, as another open source tool that was inheriting open source components, then it should be factored into the threat model for PyTM or for the commertional application.
So let's do a little thought experiment. Go ahead. Make your point.
No,
do a thought experiment.
You go.
Okay.
You go.
So the way he wrote this, if you're a software company, so let's just pretend we're not threat modeling superstars, right? Because we kind of have an unfair advantage because we've studied this thing. You guys have written the book, what I think of as currently the book on the topic, right? So software developers are not in, like a software developer at a software company does not have the superpower of threat modeling. Maybe they do, but they don't have the knowledge and experience that we
want them to have.
We want them to have, yes. But so I guess how does that change the conversation though about how they use a component and consider the security ramifications of that component?
That's a wonderful question, a wonderful thought experiment, and I'm happy that I shut up and let you introduce it before. Because now I can go exactly to where I was going before. Let's imagine let's respond to your thought experiment with the quintessential open source component that everybody uses, crypto. Aside, if you are doing your own crypto, you shouldn't, unless you are a cryptographer. So a developer looks at the crypto component that they decided to use. Okay, their threat model assumes from the beginning that whatever algorithm is in there, the implementation is good. The implementation is well done. He doesn't have, and I wouldn't have, the mathematical acumen to look into the code and decide from that this is the sound implementation of a crypto algorithm or not. But in their threat model, they are going to say, okay, what happens with the keys? Where do I store them? What's the size of the key? What's this? What's the cipher? What's the mode of the cipher? And so on and so forth. But then comes the one question that every developer should be able to put in their minds, even if they don't know all this stuff. What happens if that black box that I am unable to understand and to measure and check the goodness of it? What happens if that black box is broken? So they should be able to design their systems with what even has a formal name, cryptogidity, where you should be able to just snap it out, put another one in, and get exactly the same things and move on.
We're talking about trust. You're talking about an element of trust that the developer has for a crypto library, that because they don't have the ability to test it themselves and analyze it, which I don't either. I couldn't analyze a crypto library.
Not quite. Not quite. I'm thinking in terms of, what if you had a car? You have absolutely no mechanical ability whatsoever. And one bright day you're driving and you start hearing clunk, 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 clunk. You don't know what it is. You drive into a mechanic. They open the thing, take out the engine, put another engine, and you happily go on your way. Might not be the cheapest solution, but it is the one that's going to solve whatever that clunk, 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 clunk was, and not going to give you problems down the road. Mm-hmm. So the open source responsibility of developer here is to assume that things could go south and be ready to snap the thing out and put something else in.
But there's a trust element to this, in that.
But that trust is assumed, because nobody is. The licenses, and the authors, they're not promising you. Trust me, they're promising you, hey, I think that for the things that I tested, for the itch that I decided to scratch, this piece of code solves it. And that's it.
And by the way, it's in the bringing that component in that those assumptions. We talk about this all the time about threat modeling, is you make certain assumptions. Hopefully you write them down. Hopefully you validate them. And hopefully you're prepared if they become invalidated. But you make certain assumptions based on the nature of the component, right? If the component comes from somebody in a questionable location, a single developer. Okay, if you try to use a crypto algorithm that's implemented by a single developer in a questionable country, perhaps, or who there may be some other issues there, you may make certain assumptions about the fitness of those algorithms and have mitigations in place, or have at least considerations in place for what to do about if things go south, right? So there's a risk. Presumably, there's a risk discussion that should happen. There's assumptions that are decided during the threat modeling exercise if you're doing threat modeling, or they're implied. I got this component. I'm going to use it. I hope nothing bad happens. I'm making a lot of implied assumptions there. Right?
Now, on the side of those assumptions and on the side of trust, since we already went that way, there is I think it's the OSF scorecards project that does try to give a measure of, perhaps trust is the wrong idea, the wrong word, but
it's more assurance. It's not trust, it's assurance, because they're doing
right. But I think that the same way that severity got changed for risk, I think that in this specific case, assurance becomes trust.
Well, assurance enables trust, right?
Yes.
I'm old school.
Yes,
like,
that's what I was
I
looking
grew
for.
up
Yeah.
learning about assurance in the late 90s and looking at evaluating products using government standards and stuff. So for me, assurance is evidence and proof that allows me to get a more warm and fuzzy that security and privacy have been handled correctly. It's not it's not foolproof. It's
not foolproof.
Warm and fuzzy.
Assurance drives and enables trust, and the more assurance you have, the better trust you can have.
Yeah.
The better you can sleep at night with the fact that you're saying, I trust this thing. Why do you trust it? Well, because I've seen their threat model, I've seen their SDL that they apply to it, I've seen their test cases, and I think they're doing everything they possibly could do. Okay, now that's assurance, and that breeds trust, and then I can now say, okay, they're doing everything they can to make this component at the highest quality and the most secure and considering privacy as possible.
Right. Izar, you have a smile on your face. What's your
thought? No, I'm thinking here to myself. We are treating trust as a transitive value when we don't really have a trusted root of trust. I mean, for example, the scorecard, we are just trusting the OSF and what they decided to measure in the scorecard.
It's turtles all the way down if you go there, Izar.
It is. But I'm looking for the biggest. I'm looking for the biggest turtle, the one on top of the elephants.
Well, I guess, and so what you're bringing up is actually an interesting point, and we're straying off topic here from Bob's original blurb, but I think it's an important topic that you're bringing up. How do you gain trust from assurance if the process of assurance is not trustworthy?
So let me bring Bob into the conversation. How do you have that trust knowing that just anybody can submit a security patch? And I say security patch differing from a patch because that security patch probably has a bigger risk associated with it than any other patch. Because it's treating something that is a security condition, a security check, security case.
So
if you're going to go there, though, just real quick, you have to separate the open source universe into projects that Matt created on this weekend and uploaded to some source repository somewhere and people are downloading versus OpenSSL, right? None of the three of us could get a security patch through OpenSSL's process at this point because we're not trusted members of the team. We have no cred or anything else.
No. We need to, that's a important area, but I think we're working up the wrong tree there, right? We do not have the ability to direct commit to mainline on OpenSSL 100%, but we could probably get a patch into OpenSSL. We could either do it by tricking a maintainer or having a good patch the maintainer reviews because they have a reputable process for reviewing commits or patches, right? And so, go ahead, Izar.
No. You.
I was going to say, so there's a precondition here. Somebody finds a vulnerability, and for the moment, let's assume it's a legitimate vulnerability. Finds a vulnerability and decides to create a fix, versus finds a vulnerability and reports it and waits for a fix to get created. So first off, somebody finds a vulnerability and reports it, or decides to try and fix it themselves and then push the patch upstream, right? And now it comes down to the project, to how what their practices are for how those patches make it to their mainline, to make it to commits to their release on this release train. You know, if you look at OpenSSL, you look at FreeBSD, I'll highlight because they have really good documentation on their website. They have dedicated maintainers who have been validated and vetted, and they have tooling and a system and a pipeline in place that has all the right checks and balances and automated QA runs and regression testing and the whole works. And that establishes trust because you have assurance in the process that allows you to establish trust that what
further
patch gets
down
pushed.
the pipeline. Not at the front door.
Throughout the pipeline. Throughout the pipeline.
Where you're trying to get your PR. You're submitting your PR as a let's call it a nothing burger in the world of OpenSSL. because
as an untrusted individual, but somebody's going to go review that.
But
before
my
it makes
point
it into the
is,
pipeline.
in a project like OpenSSL, which has been funded now. I mean, I remember the days when there was 2 guys that worked on OpenSSL in their free time, and everybody built their products on top of it. So that's a whole other.
That means that at some point, OpenSSL was a weekend project.
It is, but
now
it's got investment, it's got full-time employees. My whole point here,
because it was foundational.
yes, but my whole point here is, Matt, if you try to submit a PR to fix a vulnerability, they're going to scrutinize the crap out of it because you haven't,
and they should.
You haven't,
Chris,
but you're not a known quantity. My point is that you will. I don't think you can sneak a PR past them easily.
Good.
So
That's
here's
good.
the thing. Why?
That's
because,
good.
as Matt said, they have this huge, tested, well-known, respected apparatus exactly for that threat model. Exactly for what if somebody tries to sneak a patch in here. And that's what makes it different from PyNTM that's developed on the weekends. That's the only thing that makes it different, by the way. But the point here is that if we are honest about it, the process is in place to put in a patch, especially a security patch, in OpenSSL, FreeBSD, Linux, things that we work with every day and that are foundational, right? Mm-hmm. They are much, much better than many companies I have seen. In a company, you could get that patch in, and many times I have seen places that don't have that in their internal threat model.
Yeah,
they could end up with like code that who wrote? I don't know who wrote it. It just showed up one day, right? But as you said on OpenSSL, that would be much harder. But then comes the question, and here we have go to the source of all wisdom, which is XKCD, and remember that the drawing that it had of like the blocks, and here at the end, somebody in Nebraska tirelessly working on that little module that everybody relies on, right?
Yep.
So let's go back to Bob, the civic responsibility. Where does that civic responsibility emanate from? Does it exist?
What is civic responsibility? Because like when I think of that, I remember the only time I've ever heard it is 2 times in my life. My civic responsibility was to vote, and it was to sign up for the, what do they call the draft here in the U.S.?
The reserve
selective
service.
service, which I don't even know if they do that anymore. I'm so old.
I think that they do.
Those are the civic responsibility
until 55. But you see, you touch exactly in the 2 points that basically define civic responsibility, right? You are participating in the social contract that makes this community that you live in a community.
Okay.
So you are committed to participating in how it is led and how it defends itself. Without those 2 things, you probably don't have a community. You have something approaching an anarchy or something like that. Mm-hmm. So the civic responsibility of somebody participating in, if we translate that to the somebody participating in the open source ecosystem, let's forget for a second about the voting, because I suppose that you could say that by bringing in a component, it's a form of voting. You are saying, I'm participating in this thing that's called OpenSSL, right? But then comes the second part, the helping defending it. By adding a security patch into something that you decided to adopt for use, not for development, for use, do you have a social responsibility to defend everybody else that made the same decision?
So can I answer that with a question?
Please do.
I'd like to look at examples sometimes as models for answering other people's questions, because sometimes it's good to make those correlations. So let me ask you. You were saying, should you, if you make a patch for a vulnerability, should you distribute it back to the community? Help the community to defend against the thing that you found and fixed.
Yeah.
And I would ask, just bring that up just a little bit. Which side do you fall on when it comes to, do you find a vulnerability? Do you sit on it as a 0-day, or do you report it responsibly upstream? So ignore whether a moment you're going to fix it, because you may not have the technical capability to fix it.
I guess I was.
But should you report it?
I was assuming we were talking on the side of good in this conversation.
I would hope so.
Okay, so let's keep on the side of good.
Yeah.
Bug bounty. You just found a problem on a third-party component as a participant in a bug bounty of a product. It's not a bug bounty of that component.
You're getting paid. Like you're gonna
right?
You're gonna register the vulnerability before, and then maybe you should go make a fix after it or whatever. But.
Right, but now if they have the civic responsibility of pushing a patch for that, you just killed the N other bug bounties that you could run to and get paid for the same vulnerability.
Yeah. I mean, that's a whole other. we could have a whole episode on bug bounty.
So, no. It's the same question because think. If those guys have a responsibility to patch and solve and distribute, then you, by pointing out the thing that gives you, that gets you money, is basically killing the golden goose. So you have to report to everybody at the same time, and now you have a race to the top to who creates a patch and gets it in. So now you are DOSing the open source component because they are going to get 20, 30, 100 patches
hold on.
time.
I want to take what you just said and I want to throw a curveball here. What if people had bug bounties for open source fixes? Not for breaking, but for building. What if you had a world where you could go and you could get paid $2,500 to fix a critical vulnerability in OpenSSL? And you were somehow vetted, like the bug bounty platforms have that vetting where you can say, I want only people that are kind of vetted and real people, and we know they're not criminals or whatever that are involved. Like, why don't we have that?
Isn't there something like that? Aren't there some projects that do get funding for other people to patch them?
Yeah, there used to be. I don't know if they still exist, but I know there's at least one or two. I remember a few years ago.
I would love to see it as Chris seems to be implying at a grander scale. Somebody with the resources to help those developers absorb those patches and test them and do all the good stuff that OpenSSL does. As a infrastructure, I would love to see that.
I mean, this is back to the breaker versus builder challenge that I've been yelling about for years and years now. Like, our focus as an industry is all on breaking stuff, and bug bounty just proliferates that. It's about, how do I break it? Now, imagine if you had to submit a vulnerability and a fix as part of the bug bounty. So you can't just break it. You actually have to fix it as well, so that the company could then go and apply that, right? Like, at least from an open source component. But
yeah, I mean, that's I think that would be an insurmountable challenge for a lot of people, but it may improve the quality of findings, right? Because you'd have to really understand the code or really understand the architecture to be able to support something like that. But I think that could get pretty challenging. Is it sufficient to drop a threat model? Like, here's how I'd fit or here's a new design. Here's how I would fix it from a design standpoint, if it's a design flaw, versus actually writing code and putting a PR in place, right? So there's probably some challenges there. But I want to call out one thing really important. Sorry, Zara, I know you have a point,
no.
But what Bob is then also calling out as civic responsibility is you make it for altruism. Is it altruism the word I want to use?
I think so, yeah.
It's where you contribute back to the community at large because it's the right thing to do, not because you get something from it. You get benefit from it. And you just got a puppy. Well, you get benefit from it, but you don't.
No, you got a puppy. You just got a puppy.
Well, you get the benefit because you made the fix. Like, you're improving your own security because you use the component. But
you're also distributing it to others. So, but without expecting anything in return from them.
We can't go any further until we address the licensing issue, right? Because there are licenses.
Wait. Before we go further than that,
they can't do this.
Before we go further than that, the builder versus breaker, two things. First, do you really think that we have that amount of people who are both able to find and fix stuff? And second, can we have a whole episode on that, please?
Yeah. Let's do. I'm gonna save an answer to that into a future episode because I think that's
awesome.
That's somewhere we can dive into.
Okay, license.
We got to deal with licenses here because one of the challenges here. This all sounds great. If you find a vulnerability and create a fix, it is your civic responsibility to ensure all users of that open source library enjoy the added security. But what about the license? And Matt, you've already touched on some of the license challenges that exist here. There are licenses that don't even allow me to, like, aren't there licenses that open up Pandora's box? If I do submit a security patch, aren't I then, I don't know. I mean, it seems like there's a licensing challenge here where some licenses are just not going to be friendly for my company to be able to make fix a security issue.
Well, and actually, that is a really important statement. There are some licenses that if you make a fix, if you make a change, you need to distribute it back upstream. Mm-hmm. Right? GPL, I think, is the big one here, right? If you make a fix, you have to distribute the fix. You have to distribute the code change, right? By the license. If you're under BSD and you make a code change, I don't care, right? BSD doesn't care, or MIT license doesn't care, right? That you make a code change, use it as is, and free to modify in any way, shape, or form. So there are some licenses that require you to push upstream, and there are some that don't care if you push upstream. And then there's some that are it's copyleft, and there's some other license types I think in there. I'm not an expert in licenses stuff, but we should find a lawyer who is that actually exposes more of your IP than just the change that you make, and that's
the one I was concerned about. Was the exposure. Izar, go.
Two things. Well, I'm very two today.
Yeah.
Push upstream or make it available. That's one.
Oh, fair enough.
Second,
yes. Yeah.
And second, because those are different.
They are different. Yeah. Sorry, I used the wrong term.
Second, why would it expose? What are you guys seeing this? What's this? I just went like this with my finger. What the?
Are you using a Mac? It's a Mac feature.
Yeah.
It's a Mac feature. I'll tell you how to turn it off later after we finish recording. Because it's funny. I love it.
What did you do? What did you do? What was the?
I don't know. I went like this with my finger.
There's various things with the one of the new releases of Mac OS where gestures get translated into graphics.
I'll give it a gesture soon.
Let the record show that Izar is now doing a gesture that is not resulting in any type of
balloons
flying around the screen.
Balloons, yeah. Anything coming out of this? Anything? No? Okay.
I feel like
forget where I was.
Do this and see.
That. There was a point there somewhere. You said two things. First one was the upstream versus something else.
Make it available.
Okay, right. And then what was the second one?
I forget. I got ballooned out of it.
That's all right.
This is ridiculous.
It's all right. It'll come back to you once we start talking about something else. So, but I think it sounds like we're all agreeing though the licenses could be a challenge.
Could be
with this thing.
No. Now remember the IP thing. Yeah, the IP. If you are putting IP into patches that you would send upstream or make available, something is very wrong.
I'm sorry. When you create a patch, that is your IP. That is IP. That is intellectual property. You have taken your brain power and written it into code.
Yes, because it's a line that one of your developers wrote. But is it IP? Like the thing that we defend as IP.
Is it trade secret versus not? Yeah,
matters. Yeah, right.
So there's secret versus not, but there's also valuable versus not.
Yes,
two different issues in regards to IP.
So what I'm saying is anything that you would write into a patch that you send upstream, by its own nature, should be something that you could print out and put it on an outdoor in the middle of the street.
I guess, is it a competitive advantage to have a patch to a vulnerability that you create yourself?
I would expect that.
Only if you are in the business of exploiting other people.
I almost said something.
Well,
really bad.
or if you want a product to work, let's say for a moment that patch is to close a hole that causes a permanent denial of service, and your product will work and everyone else's won't.
Right.
I mean, that's a competitive advantage.
Yeah. Which would would not comply with Bob's statement here, though. Like it would not be. You would not be being a good member of the community.
You are not exercising your civic responsibility.
Right.
Yeah. I mean, I don't know. I think that's a good place to leave this one for today. I think I want to reiterate something Izar said at the beginning. we love CISA. We love what they're doing. So this is not we're not attacking this statement. We're just trying to unpack it and understand it and think about it and ultimately help more people to hear what Bob put into this post, because we thought it was really powerful statements. And we thought there was a lot to unpack there. As you saw, it took us 40 minutes to unpack it. So once again, thanks, Bob, for putting that statement out there. Thanks for all the things you're doing at CISA. We're definitely big fans of Secure by Design, Secure by Default, and all the work that's going on there. So thanks, folks, for tuning in to another episode of the Security Table, and stay tuned for whatever the heck we decide.
Stay tuned for Isaiah and more Mac wonderment.